Real apps handle sensitive data, your API keys and database passwords, and your users' personal information, emails, phone numbers, medical record numbers. The danger with an AI agent is that any of it can leak into a prompt, a log line, an external search. mAIvn's answer is a hard boundary. The model reasons about your data without ever seeing the actual values. Let's see how. Here's the boundary, and it's worth being precise about where it sits. It's not your machine versus the network. Your data does travel to mAIvn's runtime. The real line is between the model and the actual values. At planning time, the model sees only a schema and placeholders, a tag where the email was, and a field named service token with just its type. It never sees the real email or the real secret. At execution time, inside the runtime, the real values are injected into your tool and held only ephemerally, kept just long enough to run. The one time anything is written down is at a checkpoint, and even that is deleted when the checkpoint is removed. Nothing lingers. The model plans. Your code runs on the real data. Two mechanisms make that true. First, user PII, the values you don't control, whatever someone happens to type. Instead of a human message, you send a redacted message. mAIvn detects the sensitive spans, emails, phones, SSNs, and more, and swaps each one for a stable placeholder tag before the text ever reaches the model. The real values are held by the runtime, keyed to those tags, ready to restore later. You don't write any detection code. You just change the message type. Second, your secrets, the tokens your tools need. You put them in agent.privateData, and you inject them with @depends-on-private-data, mapping a data key to a tool argument. Now the model knows a string argument named service token exists, its name and type, but it never proposes the value. At call time, mAIvn fills in the real token just before your function runs. And if your tool ever echoes a secret in its output, the runtime redacts it on the way back. The secret is write-only. Use it, never return it. Let's run it. First, preview redaction shows what the model will see. No model call, just the redaction. The email and phone are gone, replaced by placeholder tags. Two values redacted. Now the real run, and watch the boundary in the trace. Redaction is applied before execution. The agent calls apply update with the secret injected, but the tool returns only a status. The token is used, never shown. Then, tool results are redacted again before the model synthesizes, so the model finishes entirely in tags. Your code holds the mapping and resolves those tags to the real email and phone. The model did all the reasoning and never touched a single real value or the secret. The same thing in mAIvn Studio. We switch the composer to redacted mode and send a message with an email and a phone number in it. Studio shows the redaction happening. The model's view carries placeholders, not the raw values, and the run completes against those tags. It's the same boundary you wrote in code, visualized. Sensitive in, placeholders to the model, real values back to you. So, two protections, one boundary. Your secrets live in private data and get injected into tools at call time, write only, never planned against. User PII comes in through redacted message and is masked to tags before the model sees it. Your code resolves the real values. The model does the reasoning. It never touches the sensitive values, and they're handled to industry security standards throughout. That's what makes mAIvn a fit for sensitive domains: healthcare, finance, support. To recap, the boundary is the model versus the real values, not your machine versus the network. Redacted message masks user PII into placeholder tags. Private data injects your secrets, write only, at call time, and your code resolves the tags to real values, while the model only ever saw placeholders, held just long enough to run and never beyond a checkpoint. Next up, tool registration. The different ways to give an agent its tools. and when to reach for each. See you there.